Hi, as part of verification methodology module, we discussed the nuts and bolts of creating reusable test benches, especially the test bench architecture. Now, in this module, I'm going to show you how you can use the powerful features of SystemVerilog language to create the reusable test benches. All right? Let's recollect what we discussed about the verification environment. Look at this. This is how we create the test bench architecture. The environment will have all the test bench components like generator, driver, monitor, and scoreboard. We connect generator with all the drivers and monitor with the scoreboard. Here there is a DUV, design under verification, and we connect driver and monitor with each interface. The DUV has got two interfaces. One is write interface, the other one is read interface. So we create write driver and write monitor and connect them with write interface, and read driver and read monitor and connect them with read interface. And all the drivers will be connected with generator. The generator is going to generate different kinds of packets like write packets and read packets. When the generator sends write packet to the write driver will convert the packet into binary and it will drive all the values as per DUV protocol. So here the write driver drives the values as per write protocol. While driving the values, basically the monitor collects all the binary values back and it converts the binary values back into packet. And then it sends all the packets to the scoreboard. The scoreboard will have a reference model. If the DUV does any data transformation, then we need to create a reference model. Otherwise, it's not required. For example, if the DUV is a processor, then you look at the input would be instruction set and then the output would be some result. So here there is a difference between instruction set and the result. So it does data transformation. So obviously we need to create reference model. If the DUV is going to be like a networking component, something like router. In case of router, what happens? You send the packet and the same packet comes out. There is no difference between output packet and input packet. In that case, we don't need a reference model. This is what we discussed. The same thing, generator generates the read packet. The read packet will be sent to read driver. Read driver converts the packet into binary values based on read protocol. And while driving those values, the read monitor collects all the values and then converts the binary values back into packet. And the scoreboard is going to compare the read packet with write packet. That's how the comparison is going to happen. And based on the successful comparison, the coverage model is going to generate the coverage value. On top of environment, we would be writing different kinds of test cases. The test cases could be how many write packets we want to generate for this particular simulation, how many read packets we want to generate for this particular simulation, or can we think of generating read and write packets. So that's how different test cases will be defined. Mostly the test case will have parameters to configure the test bench, how we want to run the simulation. So this is how we define the verification environment, and this is how we create different test cases. And with the help of test cases, this is how basically we run the random simulation. This is what we discussed as part of verification methodology module. All right. This is our proprietary material. Please read this confidential note. Okay, this is the agenda I planned for this module. I will explain why SystemVerilog, how it's different from HDL, And then I will explain all the concepts, like what we mean by transaction and how it can be defined in SystemVerilog, why we need interface, and how we make the connections at the top level module, especially for the RTL, using SystemVerilog interface and how it's different from Verilog ports. We will also discuss about verification approaches, fundamentally how we approach verification. What it truly means is how we try to generate different kinds of scenarios during simulation. That's what I'm going to explain. And then I will explain object-oriented programming, how we can apply this programming concept to create reusable test benches. And there are features available, inheritance and polymorphism as part of OOP, and how we can apply those features to create reusable test benches beautifully. And then we will discuss about randomization, how we can generate random stimulus, and what we really mean by constraint random. And then we will also take a look on functional coverage, how it's different from code coverage, and how we can generate functional coverage from the stimulus. And then finally, we will look at how we can make use of all the language features to create the reusable test bench. All right.